Hey guys, this is the second video in a series of two, and on this one I want to use synthetic division to divide polynomials. Let's do it. Hey guys, and welcome back to your channel. This is Franck, and if you have not done so already, go ahead and subscribe to the channel so you can get more videos like this. So today we're going to be focusing on synthetic division of polynomials. And so let me give you a quick example. So if you had the function f of x equals to x cubed plus 4x squared minus 5x plus 5 divided by x minus 3, if you had to simplify this rational expression, or in other words, divide these polynomials, the numerator and the denominator, you could either factor the numerator and the denominator, which in this case is not going to be easy. And so when that doesn't work, you can go ahead and try dividing polynomials, which you can do by using long division or synthetic division. And so in my last video, note 38, I talked about long division. And so let me remind you here how that works. So to do long division, you have to first put your divisor here, x minus 3. And under the division sign here, you're going to put your dividend, which is your numerator. So I'm going to have x cubed plus 4x squared minus 5x plus 5. And so the next thing you have to do here is look at your leading coefficients and divide them. So I'm going to have x cubed here as my leading coefficient and x as my leading coefficient here. If I divide them together, I'm going to get x squared. That's going to go up here. And then I'm going to multiply that by the divisor. And so I'm going to have x squared times x equals to x cubed. Then x squared times negative 3 equals to negative 3x squared. And so with that, I can go ahead and subtract these two. The leading terms here are going to cancel. And so what you're going to have here is 4x squared minus 3x squared, which is going to give us 7x squared. And then you can bring down the other terms here because there's nothing to subtract them with. So you're going to have 5x here and 5. Next, you're going to just repeat the process. So I'm going to have 7x squared divided by x. That's going to give me 7x here. And I'm going to go ahead and multiply that 7x with the x minus 3. That's going to give me 7x squared minus 21x. So subtracting these two expressions is going to, again, cancel the leading terms here, leaving me with just negative 5x minus 21x, giving me 16x. And then I'm going to bring down the 5. And since the degree of your answer here is just 1, which is the same as the degree of the divisor, you have to go on. So again, you see that your leading term here is going to be 16x. And so you're going to have to divide that by x, and you're going to get 16, which goes up here. Then you can go ahead and do 16 times x minus 3. That's going to give you 16x minus 48. And so subtracting these two expressions together would cancel the leading terms and then give you 5 minus 48, which is equal to 53. And so since 53 is just a number, the degree of that is going to be 0, which is less than the degree of the divisor, which happens to be 1. And so in this case, you can actually go ahead and stop. And so this right here is going to be the remainder. Up here, you're going to have the divisor, the quotient, and the dividend. And so you can go ahead and rewrite your function f of x as equal to the quotient plus the remainder divided by the divisor. And so you're going to have x squared plus 7x plus 16 plus 53 divided by x minus 3. And so this is how you would do this particular problem if you were to use long division. Now let's see how this will work out if you were to use synthetic division. Now the first thing you should know about synthetic division is that the divisor has to be in a particular form, and that is x minus c. And so if your divisor is not in the form x minus c, you will not be able to use synthetic division. In that case, you're going to be stuck with just long division, or factoring the polynomials and reducing the rational expression. And so in this case, since our divisor happens to be x minus 3, our c here is going to be just 3. And so the setup for the synthetic division is going to be as such. You're going to have to first put c here. So we're going to have 3. And then you're going to have to write all the coefficient of the dividend right here. And so in this case, it's going to be 1, which is the coefficient of x cubed, then 4, which is the coefficient of x squared, then negative 5, which is the coefficient of x to the power of 1, and finally 5, which happens to be the coefficient of x to the power of 0, also known as your constant here. And so once you're done with that, you can go ahead and start the process. And so the first thing you're going to do here is bring the 1, the first coefficient of your dividend, And then after you're done with that, you're going to go ahead and multiply that by c, which happens to be 3 in this case, and put it right here. And so once you've done that, you can go ahead and add these two. So you're going to have 4 plus 3. That's going to give you 7. And so once you have 7, you can go ahead and repeat the process. You're going to have to do 7 times c, which happens to be 3 in this case again. And so that's going to give you 21. And so you put it right here, and then you go ahead and add it again. And so negative 5 plus 21 is going to give you 16. And so you can go ahead and multiply 16 by 3 again. That will give you 48. And so 5 plus 48 should give you 53. And so this is the whole process. It's very simple and quick, way faster than long division. But the caveat here is that your divisor has to be in the form x minus c. And so once you're done with that, you should know that the remainder for this division is going to be this last number right here. And the rest of these numbers are going to be what the coefficient of the quotient are. And so in this case, since you have 3 coefficients for the quotient, that's going to be a polynomial that has 3 terms, also known as a quadratic function. And so you're going to have f of x equals to x squared plus 7x plus 16 plus 53, which is the remainder, divided by x minus 3. And that will be it. Okay, so let me give you a variety of examples so you have a clearer picture of how synthetic division actually works. And so for my second example, I'm going to have g of x equals to 5x cubed plus 6x plus 8 divided by x plus 2. And so in this case, we want our divisor to be, again, still x minus c. So since our divisor here is x plus 2, that can be rewritten as x minus 2. And so that would mean that our c happens to be negative 2 in this case. And so I'm going to go ahead and put negative 2 here on the corner. And then I'm going to go ahead and write my coefficient for my numerator, also known as the dividend. Now you will notice here that my dividend happens to have a degree of 3, which means that I'm going to have 4 different coefficients here. As you can see, the coefficient for the x squared term is missing, which simply means that it's equal to 0. And so when you go ahead and write the coefficient for the dividend, you have to keep that in mind. And so I'm going to have my coefficient here as 5, which is the coefficient of x cubed, then 0, which is the coefficient of x squared, then 6, then 8. And so with that, my setup is complete, and I can go ahead and actually do the synthetic division, and I'll be done. And so I'm going to go ahead, and the first thing that I would do here is bring down the first coefficient, 5. Then I'm going to go ahead and multiply that coefficient by c, which happens to be negative 2 in this case. So that's going to give me 5 times negative 2 equals to negative 10. And so I'm going to go ahead and add these two things. That will give me negative 10. Then I'm going to repeat the process. Negative 10 times negative 2 is equal to 20. Then 6 plus 20 is going to be 26. And again, 26 times negative 2 would give me negative 52. And 8 plus minus 52 would give me negative 44. Again, negative 44 here is going to be our remainder, while the rest of the coefficient here are going to be the coefficient for our quotient. And so since I have 3 coefficients here, our quotient is going to be a quadratic. And so I'm going to have the function g of x equals to 5x squared minus 10x plus 26 minus 44 divided by x plus 2. And I am done. Okay, so one last example to make things just sink in. And so I'm going to have the function h of x equals to x to the power of 5 plus x to the power of 3 minus 2 divided by x minus 1. Again, in this case, our divisor, we should be in the form x minus c, happens to be here, x minus 1, which means that our c happens to be 1. And so I'm going to put that here on the corner, 1, and notice that in our dividend here, we are missing a bunch of terms. We are missing x to the power of 4, x to the power of 2, and even x to the power of 1. So all of those coefficients are going to be 0 by default. And so when I write the coefficient for my dividend here, I should keep in mind that since the degree of my dividend is 5, I need to write 6 coefficients here. And so I'm going to have 1 for the x to the power of 5 term. Then I'm going to have 0 for the x to the power of 4 term. And then I'm going to have 1, then 0 for x to the power of 2, then 0 for x to the power of 1, then negative 2 for x to the power of 0. And with that, my setup is complete. And so I can go ahead and just bring the first coefficient here. and so that's going to be 1. Then multiply that through, it's going to be 1 times 1 equals to 1. Then 0 plus 1 is going to be 1. Then 1 times 1 is 1 again. 1 plus 1 is 2. Then 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. And negative 2 plus 2 is 0. And so in this case, our remainder happens to be 0, which means that our divisor, x minus 1, is actually a factor of the dividend. And so x equals to 1 is actually a 0 for the dividend x to the power of 5 plus x to the power of 3 minus 2. And so with that, since our quotient here happens to have 5 coefficients, that's going to be a polynomial of degree 4. And so our function h of x is going to be equal to x to the power of 4 plus x to the power of 3 plus 2x to the power of 2 plus 2x plus 2. And of course, plus 0 divided by x minus 1, but that's just 0, so I'm not going to bother writing it down. And so with that, we are done. And as usual, if you would like a copy of this particular note, check out the descriptions below. If you like the way I break down the material, give me a thumbs up, and I'll see you in my next video. Bye-bye.